So moving right along, this is video number 3 in nomenclature. In this video we're going to deal with polyatomic ions. And you probably remember what polyatomic ions are, but let's quickly just define that. That is an ion composed of two or more atoms bonded together by covalent bonds. So these particular ions stay intact when an ionic species might dissociate or break up. Alright, so you are familiar with some of these, I'm sure, from previous years. Let's just have a quick look at them. So sulfate is an SO4 2- formula. So that's the formula for the sulfate ion. If I was to do a quick Lewis structure, excluding most of the lone pairs of electrons, that Lewis structure would look like this. And so this is what is kind of important in terms of these polyatomic ions. These single dash lines, there's 4 of them. Those are the covalent bonds. And so those covalent bonds remain intact when the sulfate might break apart from another different cation. And so that whole species with this charge of 2- remains intact, and so it is always referred to as the sulfate ion. That name will not change because that means sulfate. And so cyanide is similar. Cyanide, Cn-, polyatomic ion, that's a triple bond N with the carbon, and so that whole species is cyanide, and it will not be anything else. The name and the formula do not change. So when we're dealing with polyatomic ions in our naming conventions, we treat them pretty much the same as we would a regular anion in a binary ionic compound, but we don't change the name of the polyatomic ion. If you recall, calcium plus chlorine becomes calcium chloride. So we actually changed the name, the ending of chlorine, to this chloride. Well, we don't do that if it involves a polyatomic ion. There's a polyatomic ion, and so this is calcium, but it is now sulfate. Sulfate, SO4 2-, is the polyatomic ion, and its name will not change. So that 8 remains the same. Just to give you an idea, there's a whole long list of polyatomic ions. There's a pile of them here that you can actually look at. I've posted this list of polyatomic ions for you, so you should endeavor to have a look at that, figure out where it is, and feel free to use it as much as you want, because the use of it is how you come to learn all of these. So there's quite a lot of them. Anyway, we'll carry on here and go about doing a few examples. So in terms of naming, it's pretty straightforward then. We simply put together anions and cations. We're going to put together magnesium carbonate, so that's obviously made up of magnesium, which you know. Let's look for the carbonate polyatomic ion. And so there's the carbonate polyatomic ion, CO3 2- carbonate. So we will put together a magnesium, if you recall from before, Mg2+, plus the carbonate, CO3 2-, and we put these together. We have to obey the zero-sum rule, but that requires one of each. Because 2+ and 2-, same charge, we'll need one of each. So that's magnesium carbonate. Well, what about ammonium chromate? Well, let's go look at these ions. So the chromate ion is a 2- ion. That is CrO4 2-. Ammonium is the only positively charged polyatomic ion you need to know at this stage, NH4+. So we're going to put those two together. So NH4+ is the cation, and chromate, CrO4 2- is the anion. And so we have to obey the zero-sum rule. And in this case, the charges aren't the same, 1+ and 2-. Well, it's pretty easy to figure that one out. We need 2 ammonium ions, but here's what you must be able to do. You put the bracket around the entire ammonium polyatomic ion, and then the subscript 2 tells us there's 2 of them. And then CrO4 for the chromate ion. So again, that is the polyatomic ion. We have 2 times the ammonium ion. And finally, for polyatomic ions, we have to bring back the stock system. Remember the stock system, where you have typically metal ions that have more than one charge or oxidation state. So that also has to be considered when we have polyatomic ions. So let's look at tin first. So tin, 2 possible oxidation states or charges, +4 and +2. And so we have SN4 and SN2. And we're going to combine those with the nitrate polyatomic ion. Now, if you remember the nitrate polyatomic ion, NO3 minus, there it is right there, don't be confused with nitrite, NO3 minus for nitrate. And so the only thing we need to now consider is the zero-sum rule. So we have 4 plus for tin 4 and 1 minus, so that becomes tin SN NO3 4, and it would be called tin 4 nitrate. Whereas tin 2 will have this formula and be called tin 2 nitrate. So there's nothing different there than we dealt with previously. It's just we have a polyatomic ion. Finally, let's look at this example involving gold. So gold is another one of those metals with multiple oxidation states. Here it is down here, Au, +3 and +1. And so we have gold 3 and we have gold 1. Now gold 3, or we're combining this with hydroxide. And so here's hydroxide. Again, it's probably one you remember. It's very common, OH minus. And so the hydroxide ion, OH minus, gives rise to the formula AuOH3. And that would be called gold 3 hydroxide. Now, I wanted to use this example because this is a pretty common mistake, and it comes up frequently with hydroxide. People will do this. And you see the problem there? They've simply forgotten the bracket. But that, in counting molecules, that becomes a bit of a problem, because if I was to count these atoms now, I have 1 gold, I have 1 oxygen, and I have 3 hydrogens. If I was to determine the molar mass of this compound as written, I'm going to get a molar mass that is out by 2 times the molar mass of a single oxygen. So simply by forgetting the brackets around the polyatomic ion, I have their incorrect formula, and that can lead to problems later, especially with mass determination. Anyway, just try to, I mentioned that so you're aware of it, and hopefully you won't do it. So here we go. Last one, gold plus and OH minus, gold 1. And I don't need the bracket here because there's only a single hydroxide ion. So I still count 1 gold, 1 oxygen, 1 hydrogen. So there's no problem there. And that would be called gold 1 hydroxide. And so there we go. Polyatomic ions and nomenclature that incorporates polyatomic ions. It's pretty straightforward, no different really than simple binary ionic species. So for your purposes, the main thing you have to come to terms with in this regard is knowing your polyatomic ions, and that is the formula and the name and the charge. And if you get all of that sorted out, it's really quite straightforward. So that concludes this particular video.